Hello, my name is Shannon Prather, Marketing Coordinator at GISinc. I'll be your moderator today. I'd like to thank you for joining us for today's webinar titled Work Smarter with Sensor Networks, the second in the series titled GeoIoT, Why Where Matters. I'd like to take a moment and bring to everyone's attention that if you're planning on joining us for any of the additional webinars in the series, you must register for the ones you wish to attend individually. You will not automatically be registered for the webinars in the series. In today's webinar, we will discuss how you can work smarter with sensor networks and IoT. We'll provide examples of how popular industry applications of sensor-based work, how this strategy is being used by some of our clients, show a demo of what this could look like for your business processes, and discuss the potential ROI of working smarter. During the webinar, we'll pause for a moment to ask two polling questions. We appreciate you taking a moment to answer the questions as they will help us gain a better insight into your organization's priorities. I'd like to encourage you to post questions throughout the webinar. We'll respond to all questions at the end. After we answer the questions and provide some closing statements, there will be a brief survey. The survey will show up on the screen after I've finished speaking. We realize you'll want to get back to your business at hand. However, please do not hit the close button until you have seen the survey questions appear on your screen. Your time to answer these short questions is greatly appreciated. This webinar is being recorded and will be posted online. If you've also registered, you'll receive a recording within a week after this webinar's conclusion. Before we begin, I'd like to take a minute to advertise the upcoming episodes in the series. We do have the first episode recorded. That was What is GeoIoT and Why Does It Matter? Today, as we've mentioned, will be Work Smarter with Sensor Networks. September 13th, we'll have GeoIoT Asset Tracking and Analytics. October 11th, Indoor Positioning Systems and GeoIoT. October 25th, the GeoIoT Partner Ecosystem. And then to conclude our series, November 15th will be the Future of GeoIoT, Why Where Matters. To set the stage for why GISinc is producing this Why Where Matters webinar series, let me quickly introduce you to our company. GISinc has solved where problems geospatially for over 27 years. With over 160 professionals and one core purpose to create insight through location technology, we help state and local and federal governments, as well as commercial industries, to improve operational efficiencies, increase citizen engagement, optimize investments in Esri's ArcGIS platform, and increase revenues. Over the past few years, we've paired that location, geospatial GIS lens with IoT technology. With this GeoIoT, as we call it, businesses can attach sensors to assets to track their location in a warehouse or storeroom, view analytics in the back end. Cities can monitor the use of space in buildings to determine whether to allocate additional resources or not. Organizations can dispatch crews when sensors alert the need for an asset's attention, saving thousands of hours previously spent manually monitoring those assets. We'll cover these applications and many more as we continue this series that explores why where matters. And now let me introduce our partner and guest in this webinar, Cityworks. Launched in 1995, Cityworks developed a better way for organizations to manage the work they do. By combining comprehensive work management system with ArcGIS, Cityworks helps local governments, utilities, and transportation agencies respond, plan, and improve their operations. This GIS-centric approach is now identified as the best practice in public asset management. Today, more than 700 organizations use Cityworks and ArcGIS to improve the lives of 80 million people worldwide. Like GISinc, Cityworks is one of only 15 Esri Platinum partners, the only provider of enterprise asset management solutions at this tier. Without any further delay, I'm excited to welcome our presenters today. Steve Mulberry is the Senior Enterprise Architect and Sales Engineer at GISinc. He has over 28 years experience in GIS, creating and architecting in enterprise systems. He started his GIS career in the United States Marine Corps as a cartographer and terrain analyst. Since finishing his commitment, Steve has been employed by both state and local governments, as well as private GIS consulting firms such as Esri, where he spent 11 years as a solution engineer. More recently, Steve has focused his attention on IoT and sensor-based technology and helping organizations find real value implementing these workflows to help improve efficiencies both indoors and outdoors. And George Moustakis, Enterprise Solutions and Corporate Partnerships at Azteca Systems. George has over 25 years experience bringing GIS-centric asset management solutions to local government and public service organizations. Georgia's committed to providing GIS-centric solutions that help communities be more resilient, sustainable, and safe, while increasing their levels of service and reducing costs along the way. The culmination of these efforts is reflected in the Cityworks software platform, where he has been involved in its inception, growth, and expansion since 1996. Steve with GISinc is going to get us started today. I hope you enjoy the webinar.
Okay, thank you, Shannon. First off, before I get started, I want to make sure that I'm unmuted and you can hear me. Shannon, I'm assuming you can hear me okay?
Yep, we can hear you.
Okay, great, thank you. All right, so as Shannon mentioned, this webinar series is going to focus on working smarter with sensor networks, looking at ways that we can innovate our communities and cities and organizations with this technology. And what I'd like to do first is just spend just a couple slides reviewing what we talked about in our previous webinar, because that's going to help set the stage for the topic that we have today. So what I'm going to do is just spend just a few seconds. We're going to look at and define again what IoT and what GIoT means and why does it matter in a context of data-driven communities, because we all realize that data is the key component when we start working with any of these technologies. So if you recall, and if you attended our last seminar, we defined the Internet of Things as basically these physical objects that are networked together and have enough electronics built into them that they can sense information through sensor technology and communicate that information and exchange that data to other devices or other objects or other systems. We defined what that meant from the standpoint of devices. We talked about wearable devices and tags and tracking and smartphones and watches, security, vehicles, buildings, energy, lighting. There's lots of great examples of how the IoT space is leveraging this technology, from virtual reality to augmented reality, mixed reality, and those kinds of things. And all this is very interesting in the way IoT is playing a large role in this space. But where we get excited about the Internet of Things is when there's a spatial component attached to these devices or these objects or these things, right? This gives us a spatial context of where these sensors sit in the world and allows us to do the spatial analytics around that. So we've coined this phrase GeoIoT, which is nothing more than a geographic or a geospatial Internet of Things. And we looked at the three types of things out there, right? These devices, and we defined that these fall into three categories: things that collect information and then send that information on. There's things out there that receive information and then act upon that. And then there's things that do both. And we determined that it's when we get to this things that do both is when we hear this word and term smart. Now, not to discount the things that just collect or the things that just receive and act on that. Those are very viable and play an important role in the Internet of Things and how we collect and receive information and act upon that. But when we deploy things that do both, then we fall into this category of smart. So you probably heard things like smart cities and smart communities and smart vehicles and those kinds of things, smartphones. That falls in the category where we have these things that do both: receive, collect, and act upon it. But I like to draw a correlation between the term smart to actually meaning data-driven. Because if you look at anything out there from an Internet of Things perspective, it's all about the information. It's information that we gather, it's the information that we receive, and then it's the information that we act on, right? And that's what's going to drive our discussion today is what do we do with that data once we get it, or what can we do? What are the options out there? We defined where we're seeing the Internet of Things pop up in the world, and we determined that we definitely live in a connected world. We looked at statistics that show us that by 2020 we're going to have about 50 billion connected devices, and those connected devices are going to fall within these top 10 sort of trending industries, smart homes and wearable devices and vehicles and industry. We talked a lot about smart communities and cities. We're seeing these technologies make their way into agriculture, retail, the energy field, especially healthcare too, both in hospitals and urgent care facilities, as well as assisted living facilities. And then the whole livestock monitoring, farming and poultry side. We're definitely seeing the Internet of Things make a strong presence in these spaces. But again, I'd like to draw your attention to the concept of data-driven. Without the data, we're not able to make these smart decisions or find ways to leverage this technology to help us make better decisions and use this information to improve the way of life in whatever field that we're working in. So what I'd like to do right now, just pause just for a quick second and have Shannon pose the first polling question. Shannon?
Thanks, Steve. Right, you should all see the first polling question. Do you currently have sensors you would like to integrate into your asset management system or your ArcGIS platform? Yes, no, or perhaps it doesn't apply. We'll give you just a few minutes or seconds to vote. All right. And with that, we'll close the poll. Thanks to all who voted.
All right, great. You should be able to see the results there. So, what, 54% say yes, there's currently using sensors within your organization in some form or fashion, and then others out there that aren't. But we're going to hopefully show you some ideas, give you some ideas, and show you some ways that you might be able to leverage that. Thanks, Shannon. So with that, I'd like to kind of make one more statement, especially to those that are already using sensors within your organization, is that we've seen over the years that this has moved from a fad to some kind of trending thing to it's part of our way of life. We in the last poll, it was interesting. The last webinar we polled how many people currently have a connected device, and it was 100% response to that. We truly live in a connected world, and we have to stop thinking about GeoloT just as a project and just as a proof of concept type of thing. We have to include this and incorporate this into our enterprise platforms. We have to think about it and talk about it in our daily planning, in our budgeting meetings, and bring this into the enterprise as a program so that we can leverage this moving forward. I'd like to show you a couple examples of some customers that are doing just that. The first example that I want to show, and we hit on this just a little bit in the last webinar, is a customer that's using sensor technology to detect outfall overage in the sewer system. So during heavy rain events, the treatment facilities just can't keep up with the load of rainfall, and so this causes a lot of problems. Especially the collection of these pipes begin to back up and outfall into the rivers and streams, and I mean, it just on the surface, this is just gross, right? It just shouldn't happen. But this particular customer gets fined heavily by the EPA if these occurrences take place. And so there's a need to monitor and keep track and help mitigate the risk when these events happen. And so what this particular customer has done is implemented sensor technology throughout their service area. So precipitation type sensors that measure rainfall, or outfall sensors that measure the discharge flow, or level sensors that again measure surcharge levels. And so the use of these sensors and the use of the way that they've incorporated these sensors within their distribution network gives them the insight in real time what's happening within the area, and they can react to that as needed to help mitigate the outfall into the rivers and streams. And we're seeing this kind of usage of sensors all over the place. We have another client that is looking to include and incorporate stream gauge monitoring sensors and establish these on key infrastructure, key bridges throughout their area. And what this will give them is the ability to monitor the level of the water as it passes under these bridges and give them real-time information back. Now we know the USGS has their series of sensors out there right now, and we can automatically, ingest that data and start using that data to do some analytics. But it's getting to a point where we can deploy these sensors, additional sensors, to key infrastructure, grab that information and bring it into the platform. And so this particular client, we helped sift through the sensor technologies out there and found out that there was one Cinex based sensor that was going to provide them with the needed infrastructure to collect information, and we're going to piggyback off of the lower WAN network. So this is a emerging protocol, a low-level, wide area network technology that is being incorporated more so throughout the United States, that allows us to install a series of different types of sensors and all communicate over this low-level, low-power, wide area network that we can collect all this information in and push that into the platform. So when we talk about a solution, and we'll get into more of that later on, that it's not that difficult to get started. Some of you, over 50% of you, said you already have sensors. I would guess that a lot of you already have the platform in place. Now it's just a matter of connecting the dots to get the data from the sensors into the platform so I can visualize the information. I can start creating these alerts to help keep me informed of what's happening, whether it's stream gauge, whether it's rainfall, whether it's a number of other types of sensors. And so what we've got at this point then is we've got data coming in from a sensor. We're communicating that over some kind of network protocol, pushing that into the platform. And once we get it into the platform, we can visualize this information. We know how to do that very well. The platform provides us with operation dashboards and solutions and templates and web maps that we can just configure to start consuming this information. And to some extent, we can create alerts, right? Send me an email alert or a text message or those kinds of things to help me or an operations center stay alert and aware of what's going on in the area. But what we want to do is extend this to the next level. We want to take the platform and allow us to then trigger events inside of our asset management system, right? And our work order management system, to initiate this actionable work that then will automatically create our dispatch or alert the field's crew or do things like that. And so at this point, what I want to do is turn the time over to George to talk to us about their asset management system, which we're going to use within this demonstration. George?
All right, fantastic. And thank you, Steve, and thank you everyone for joining us today. Steve, if you could please advance the slide here. Great. Yeah, so we like to think of Cityworks similar to ArcGIS, where on the one end of the continuum is a system of engagement that enables and improves your interactions with your customers and citizens. And on the other is a system of insight that brings to light critical information to help you plan your next moves in a more informed way, because your awareness is greater, your spatial awareness is greater. And in the center is a system of record where all the work you do accumulates and comes together on a GIS-centric foundation. And we feel that foundation is really key because your commitment to your GIS only continues to increase since it is one of your most critical business systems. So back in 1995, as Shannon mentioned, we saw great opportunity in marrying GIS to operations in a more significant way. And our GIS-centric approach is now a best practice. So let's take a closer look at what Cityworks does and how it can play a role here. Steve, if you can advance, please. So a common work pattern that you'll find in Cityworks is work will initiate from a public inquiry or from an internal source. that service request can be transitioned to an inspection for either verification or for an asset condition assessment. And from there, a repair or a replacement of that asset occurs, and it is here that resource costs are applied. And finally, the history that's built up over time can be reported, and more importantly, it can be used to learn from as well. Now again, this is just one example. A user can come into any one of these areas directly, and the workflow can be ordered in the way you need. Next slide, please. But you also have ArcGIS, right? And it's important to note that while Cityworks comes ready-made with web and native device applications that serve your people from the back office all the way out to the field, you also have a whole host of Esri apps that you rely on, and they can be incorporated as well. So for example, you could use Collector with Cityworks mobile app on a tablet to seamlessly perform updates in GIS and complete your inspections and work orders all while you're in the field. You can leverage insights for ArcGIS to analyze your data in Cityworks and visualize it in ways that are easy to create and to consume. And you can also do this in ArcGIS Pro, this sort of analysis in 3D to see emerging hotspots of problems. You can combine Cityworks with operations dashboards to provide management with a real-time view of your organization's performance. And the point is that Esri provides a whole host of products that can be used to get information into and out of Cityworks as well, in addition to our own. And all of these, what I like to call human interfaces, enable your users with easy-to-use tools to accomplish their objectives. But importantly here, and why we're all here, is there are ways to bring this information into Cityworks without these human interfaces when the opportunity exists. And as Steve mentioned, many of you currently have the sensors and devices in your organizations today that could drive that. And they're constantly reporting, and we want to show you how that information can come into Cityworks already assigned, already prioritized, and ready to be worked on. Steve, back to you.
All right, thanks, George. So what we want to do is we want to walk through a visual of what George and I are going to show you here in real time. So we're going to look at sensor technology. We're going to find ways of working smarter by integrating this sensor technology into the platform and into the asset management system, Cityworks. And so it's important to start off with the sensor technology. And that sensor, again, could be just about anything. And we'll talk about some examples of that. That data has to be communicated over some kind of protocol. And there's lots of different protocols out there. I mentioned one in one of the examples that our customers are using with the LoRaWAN protocol, but there could be cellular or Wi-Fi or RFID radio frequencies. But that's important as we go through the process of determining what kind of sensors you're going to use, the protocol you're going to use to communicate that on, and then getting that data into the platform. And the key for getting information into the ArcGIS platform is GeoVent. So we leverage GeoVent to ingest those data feeds to bring them into the platform. Once we have them in the platform, then we can very quickly visualize and monitor that information from a visual perspective, dots on a map or areas of a map or the visuals that's tied to those sensors, points, polys, or line representations of whatever we're monitoring out in the field. And when I say field, this could be indoors or this could be outdoors as well. All right, we'll see some examples of that. And that's all doable right now, right? You have sensors, we have ways of communicating that in, we have GeoVent to push it into the platform. The platform gives us tools to visualize and monitor that information. But what George and I are kind of explaining is that we take it one step further and we also let the platform push it to our asset management system, which then gives us the ability to do some automated dispatch or field crew notifications, right? We build these service requests that automatically alert and dispatch folks to react based on the level of the service request indicates. And so as we look to leverage this technology and find ways to integrate sensors into this process, we've come up with a list of things that we think are low-hanging fruit. right? Stream gauge monitoring is obviously one of them. Rainfall, right? Flood risk mitigation. Those two kind of work hand in hand. Bridge integrity. So as we're looking at streams and rainfall and flood risk, we can have sensors on our bridges to help us determine the viability of the bridge. Citizen engagement is a big one. We see this with Waze out there right now, allowing the citizens to be part of this process. Well, in a sense, a citizen is a sensor, right? I walk around in my community every day, and I'm monitoring what's going on, and I can be part of this process. I can send requests for fixing potholes or graffiti or whatever it might be, and that could also trigger these service requests. Trash container capacity. We've heard this over and over again, where communities will send out individuals and drive through their community and look at these containers to see if they need to be emptied or not. Well, why not put a electrostatic sensor within inside these containers and then notify me when it reaches a particular threshold? Same thing with catch basin, cleaning these catch basins. Put sensors out there, let me know when it needs to be cleaned instead of me having to just drive around and assume. Road conditions plays a big role. And then SCADA and HVAC. I wanted to kind of point these out because first off, we're not trying to replace SCADA systems. We know they've been around for decades and they've been doing this sort of thing for a long time, right? Been collecting information, they've been providing user interfaces and helping monitor things like capacity, pressure, and rate with inside these water distribution systems. But notoriously for a long period of time, these have been sort of closed systems. Those are becoming more open now, and so we can complement our existing SCADA systems if we use those right now with these other types of sensors for stream gauge and rainfall and trash container and catch basin. We can complement those systems. And as we talked about going from outdoors to indoors, right, we can use these same types of sensors to measure environmental impact within inside of a space, right? Temperature or occupancy or usage of building space, or the patterns that people use within inside our facilities. We've seen a lot of desire and discussion around permitting systems. When someone comes in for a permitting, where do they go? Who do they meet? Where does the plan go? When they get the plan submitted, can we put an RFID tag on there and track that, the life of that activity? And so I'm sure we're just kind of scraping the surface here with ideas and ways of using this technology. And we encourage you folks, almost 200 folks of you listening in right now. What are you thinking about? What are some ideas that you may want to see this integration with? And we'd love that feedback. So what we're going to do now, George and I are going to sort of tag team a demonstration. It's always fun to do a live demo in a webinar. So we're going to tackle this. What I'm going to do is end this PowerPoint here real quick, and I want to make sure you guys can still see my screen. And Shannon, if you could verify that, that'd be great while I get things set up here.
Yep, we can see it.
All right, awesome. So I got several applications running, several web browsers and some things going on. But what I want to kind of highlight here is on the right, we've got this simulated stream gauge monitoring sensor on this bridge. Now this bridge just happens to be just a few miles away from the GISinc Birmingham office, which is right here in this location. And this is sort of the main thoroughway into this business complex. And so it's important to understand the activity that's taking place in this area. So we're going to use this as an example. So we've got this stream gauge sensor out here bringing data in. If I click on that information, we can see it's currently at 69% capacity, the water that's flowing underneath that bridge. Well, where does that data come from? Right, it's coming from a sensor. Now, obviously that sensor, in order for me to invoke this sensor and change the value, the sensor is actually running on my desk right now. And this is what it kind of looks like. It's nothing more than a little Raspberry Pi with an ultrasonic sensor that allows me to determine distance values. And although this is sort of a prototype concept, these are the same types of sensors that we have used and deployed for doing just this exact same thing, monitoring the stream gauge. So what I want to do is kind of show you how this is behaving. So on my desk, I got this sensor, and it's right now reading about 69% capacity. And over here on the left, this is GeoVent. This is within GeoVent. Once I configure the sensor to talk to GeoVent, I can look at the raw data coming in from that sensor. And as you'll see here, we're seeing 69.175, right? If I come back here to the map and click on it, we should see, about that same kind of data coming through. It's coming through about every second. So I must have hit it right about here with the 69.28, right? So that data is coming in a raw form. And because it's coming through GeoVent, I can shove that right into a web map, associate that with a geospatial location, right, which is the GeoloT component of this whole discussion, right? We want to be able to have and assign a spatial location to our sensors. In this case, we have one. And the legend is showing us current activity right now. So we've got raw data coming in. We've got a map showing me visually what's happening at that location based on the sensor data coming in. The third piece of this is the Cityworks Online. So Cityworks Online gives me the ability to configure these service requests through an inbox. And so I've set up several inboxes here that's going to tie directly to either that stream gauge sensor, which can give me some flood warnings, or environmental sensors that might give me temperature readings inside of a space, or capacity readings that are coming from trash containers, or pressure coming from water mains or water pumps or whatever, right? So you can kind of see the idea here is that we can have multiple sensors coming in through the platform into Cityworks Online that establish this connectivity between the data and the service request and the actions that can be taken place from those service requests. So with those three things in place, I want to kind of try to do this in real time here. So I'm going to take my sensor and I'm going to start increasing that value here. So you should see that 69 to start to increase, 70. We're starting to get up to a certain threshold where I've configured inside GeoVent that once it gets to a certain temperature, and I've set it to be 75, or I'm sorry, the value 75, the data coming in from this sensor, once it hits that threshold, to automatically start doing some things for me. So we're almost there. It's coming up. You'll see the map. It's starting to reflect from a symbology standpoint, and now you see it turn red. We've met that threshold. So now some things behind the scenes have already started to happen for me. One is I've gotten an email request saying, hey, we recognize that your sensor has met its threshold. A service request has already been created for you. So I come back over here to Cityworks and I look at my inbox. We'll see that sure enough, just now a flood warning a service request has been created for me inside of my dashboard. So as a dispatcher or in the ops center, or whoever's monitoring these things back in the office can see these things coming in. Well, my first reaction would be to open that up and start doing things with it, but I don't have to, because Cityworks Online has already doing those things for me behind the scenes. And so what I want to show you here now is I'm going to bring up my cell phone, and we're going to see how this works. So I'm going to log in to Cityworks Online through a web browser. So we'll go to my bookmarks and we'll activate Cityworks Online, and I can see the same kind of dashboard there where I have my flood warnings, my condition warnings, capacity warnings. And so I'm out in the field, I bring up my dashboard, highlight the flood warnings, and I can see that yes, there was one attached to me, dispatched to me, submitted by Adam, and today I'm Amy. So and I'm good with that. But now I can start reacting to this. So I can drive out to the bridge. I can open up this service request. I can see a lot of information that's already been deployed for me and filled out for me. So I'll add a few more things here. So I'm going to yes, I'm going to investigate this. I'm going to put in today's date and time that I'm out there. I'm looking at it right now, and yes, it looks like an emergency. We do need to create a work order. So let's make sure we automatically do that. Next thing I'm going to do is I'm going to minimize that. I'm going to come down to comments, and within my comments, I can add some descriptive narrative to what's happening here. And what's neat about this is I can do this from my phone, so I can use the voice commands to do this. So I'll say something like, "Bridge is at risk," and we'll save that. So you can see that coming in on the screen there. We'll minimize that. I can input some incident information here. I'm going to skip that for now, but what I do want to do is take a quick picture and add that as an attachment. So we'll go out to my camera. I just took a picture of that. We'll put the picture that I just took of that bridge and the water flowing underneath it. It's uploading it to the platform, the solution. Once it's there, we're good. And I could continue and fill out some other information there, but you can see from this interface that it's very user friendly, and I can pick the categories that's most important to me, and I can work this event, right? When I'm ready, I'll hit save. So now again, let's kind of backtrack here a little bit. The data's coming in from the sensor. The platform received the information. I visualized that on a map. The platform also, based on a threshold that I configured within GeoEvent, also pushed and triggered events to take place within Cityworks Online. Now, if I come back here to the dashboard, and now as a dispatcher, I can look and to see who is taking care of this event and what actions are taking place. And so I can see in here that the bridge is at risk. I can scroll down. I can see they've attached a picture here, so I can open up that picture and see that yes, indeed, that there is some high water level that's flowing under this bridge. So I can bridge the gap between the data and the need to react against that data that's coming in from the sensor. And then finally, right here from Cityworks Online 2, because it's part of the ArcGIS Enterprise platform, right? I can open up right inside Cityworks a map that is the same map that I would be using inside the platform. I just bring it inside of Cityworks. So as a dispatcher, I don't have to have a separate tool, and I can see that yes, that event has been logged. I can open that up. I can see the information here. I can see who's acting upon that information. I can link back to the service request. I can see that the work order has been created, and I can just follow this through the life cycle of handling this event right here. So I've talked a lot at this point right here, and I showed you some different things in the way this information could communicate through the evolution of getting the raw data to reacting to the data that's coming through. George, is there anything you want to add from this perspective of the Cityworks Online?
Yeah, and Steve, that was really awesome and a really nice, simple example of how this can come together, and really using the APIs and the web services of Cityworks that we make available for these types of scenarios. The one thing I wanted to mention is, Steve, you're absolutely right. Everything we're doing right now is cloud hosted, and it is available online, and you can tie together. So that's an important distinction here, because a lot of the organizations that are on the call today and a lot of our current customers are making that move to the cloud more and more, and not managing on-prem infrastructure. So that is possible, but I wanted to also mention that you can deploy this in your on-prem environments as well, or in a hybrid environment where part of it is on the cloud and part of it is on-prem. So I did want to make sure to clarify that.
And that's a good point, because those who are leveraging ArcGIS Online as a cloud-hosted platform could also then tie directly to Cityworks Online and have a complete hosted environment that's managed by the cloud infrastructure, or on-premise, or at hybrid. So it's very flexible in how you implement this technology. So with that, let me restart the PowerPoint here, and let me make sure that you guys can see it. So Shannon, again, please be my eyes here.
Yeah, we can see it.
Perfect. All right, so at this point, let's pause again for a second, and let's have Shannon have our last polling question. Take it away, Shannon.
Sure. You all should see the poll now on your screen. After seeing this demo, are you inspired and ready to get started with sensor-based IoT? Yes, maybe not yet, or perhaps it doesn't apply. We'll give a few seconds for everyone to submit their vote.
Yeah, and as you're thinking about that, remember the different types that we kind of outlined there, from stream gauge to rainfall to catch basin to the many others. And there, again, there's probably others that we're not thinking about. So if there are, maybe say, hey, not yet, or yes, but this is why. You didn't list it out there. Give us some feedback that we can use to help improve the way we integrate with these sensors.
Very good. And I'll close the poll.
All right, I'm interested to see the results there. So good. So 54 of you say you have sensors, and 62% say you're ready to go. So that's a good sign. I love those numbers. So let's talk about, and let's move into the return of investment that will come from implementing this technology. So I always like to show this quote. This is a quote from Kevin Ashton from MIT. This was a quote made almost exactly 20 years ago to the date. He said, if we had computers that knew everything there was about things using data gathered without any help from us, right, we would be able to track and count everything and greatly reduce waste, loss, and cost. Now, you just saw that in action, right? We saw sensors that and things that are collecting information and gathering that data without any help from us, right? Stream gauge, catch basin, rainfall, whatever it might be. That data is gathered and then can be used then to help reduce the waste, loss, and cost. So, for instance, of the stream gauge one that I just showed you, I used to live in North Georgia, and the rainfall up there was notorious, and bridges would constantly get this flow of water underneath them, and I would regularly see people, field crew, drive out there and stand out there and watch as this water would flow. Well, what if they had sensors on them? Then instead of wasting time to get out there and just physically monitor that, let the sensors do the work for us, and then mitigate that process. So as we look at return on investment, we can see that there's definitely some opportunities for optimizing the personnel, right? What are they tasking to do? What's their workload? The vehicles, the capacity of those vehicles, or the maintenance associated with those vehicles. Every time we send things out, trash containers disposal is one that comes to mind. The fuel and maintenance costs of those vehicles, the reallocation of resources. There's probably several others here that we could use to illustrate the reduced waste, loss, and cost. And to play on what Kevin mentioned up there in that statement he said. So I see it as the true ROI for GIOT is almost entirely dependent on the data that's collected from these connected devices. So that real-time insights that we get back, what you just saw through the demo, is what's key here. And if we use that strategically, like we take that data in, we put it in the platform, we're visualizing that information, we're shoving it to Cityworks. Cityworks is automatically dispatching it. We're strategically using that data, right? We have the capability of reinventing the business processes that are used within our organization to then greatly reduce waste, loss, and cost, right? I strongly believe that. And I think you guys are seeing that right now. So how do you get started, and where's the beginning point? We kind of like to think of this as a solution, right? Work smarter integration, and lack of a better word, I'm calling it WSI. I don't think that'll stick, but what we're saying here is that the first step is to identify the sensors, right? Identify the sensors you already have or the ones you don't have and need, and let us help you determine what's best for the problem you're trying to solve. Then we integrate that sensor data into the ArcGIS platform. And in most cases, you already have this in place. You already have the sensors and you already have the platform. So we're not selling you anything new here. We're just helping you leverage the investment you've already made in here. And at this point, you can immediately see the impact. You can visualize this information and you can configure the platform to send out these alerts. But then we extend that one step further. We take ArcGIS and we integrate that, or better yet, just configure that into your asset management system, predominantly Cityworks, as we just showed you. This is what we're constituting this solution. And this could be small, 5 sensors, right? Again, we're not trying to replace your SCADA environment. We're trying to introduce a way to complement that space. So from 1 sensor up to hundreds of sensors, this solution sort of fits all categories there. And we're finding, again, to kind of bring it full circle here, that the data that we get from these sensors can drastically improve or reduce the waste, loss, and cost in any industry, right? From smart homes to wearables, all the way down to healthcare, energy, especially within our cities and communities. So what I'd like to do here is just kind of pause for a second and let's look at some of the questions that have come through during the last 40 minutes or so. Shannon, maybe you can share some of those questions with us. And if you have any questions or thoughts, now's the time to kind of ask both George and I.
Absolutely. There's been several that have come through. One of them, has ArcGIS been integrated into electric vehicle charging stations?
So interesting. So that is another sensor, right? These charging stations are physical devices that can be tied spatially to a ground, and that information then could and can be easily integrated into the platform. Now, I don't know of a out-of-the-box connector, so the platform, especially through GeoVent, has what we call input connectors, and I don't know specifically if there's been an input connector created for specific charging stations, but my guess is that that information is available through an API or an SDK, and the way the platform is configured, it would be just easily getting that data and shoving it in through either a common protocol like a REST endpoint, or through what we've been developing over the years through our GeoIoT bridge, where we have starting to connect multiple types of sensors into the platform through our bridge. So I would say that there's definitely a way to get that data into the platform.
All right. The next, how do you configure the sensor with GeoEvent, and can you connect it to a service request? Also, can you share a how-to video on that?
That's a great follow-up, and maybe what we'll do is, Shannon, I'll create a quick sort of 5-minute follow-up a video webcast that I'll show you how that works. But basically, we first look at the sensor, and in most cases, we're finding that a sensor can push out data through a common protocol like REST or JSON or GeoJSON. If that's the case, then the configuring that to GeoVent is just using one of the out-of-the-box connectors, the REST ingestion or the JSON or the GeoJSON and input connector. If it's not, then that's where we deploy our GeoIoT bridge, where we have already been looking at many different sensor technologies and have started to build this connection process to help bridge that gap quicker. So look at your sensor, look to see what we can get out of the box from that sensor, and then react based on that. If it's a JSON, GeoJSON, or REST, then it's pretty straightforward on how that works. If it's not, then it's not that difficult to get that in, and we've seen this happen time and time again. So I would say it's pretty straightforward, and yes, I will definitely follow up with a sort of a video or maybe another webcast to show exactly how to make that happen, how to configure that.
Right. The next one is more of a statement. Maybe you could just comment on it. What was written in was, the purpose of a sensor network integration would be to allow users to see which stations are operative and in use versus inoperative or occupied.
Perfect. And a perfect example of how you would take this information of these stations and use like the operations dashboard to put red, yellow, and green dots on the map to show what's operable, what's not operable, or what's being currently in maintenance mode. So that would be a perfect example of how you can take that data and shove it into the platform. And then once it's there, if the devices have sensors on it that can tell us when it's inoperable, right? That's when you kick a service request off in Cityworks and then dispatch someone to go do an inspection. Perfect example, yeah.
Let's just do a couple more questions. Is there a data source that LoRaWAN doesn't work with?
So there is some challenges with the LoRaWAN network. One, it's not an industry accepted protocol yet in the United States. Over in Europe, it is, and so we're seeing a lot of traction there. But we are seeing a lot of folks starting to implement that more throughout the states. So that's one challenge. The other challenge is distance to the antenna. So you have to install these antennas in strategic locations that allow me to connect to the sensors that are out in the field. And these sensors, in some cases, can go up to a couple miles in their service area. So you have to kind of be careful with that. But from a protocol standpoint, it's the industry standard, right? It's a REST JSON or even GeoJSON protocol. So we're pretty happy with the way we can get data in and out of that platform. And what we're seeing too, and I'm going to throw out a buzzword here, is a technology called Node-RED. So Node-RED, if you do a quick search on it, it builds on top of Node.js, and it's allowing developers like us to quickly implement the technology needed to connect to these LoRaWAN devices and shove them into the platform. We're getting some great traction and some good some excitement from our developers because of the way we can integrate with these systems. Hope that answers that question.
Perfect. And just one more, and then we'll wrap up. How could sensor-based networks help with security risks?
Let's see here. So when we talk about security risk, and that's I know that's a sort of an umbrella term for all kinds of security risks. So it could be data security risk, space security, indoors, outdoor. So I would like to look at that a little bit further. Maybe whoever wrote that question, maybe send an email directly to me, right? steve.mulberry@gisinc.com, and let's talk about that further, because I think there's a big play in the security space to leverage both sensors, the platform, and an asset management system like Cityworks to mitigate that. Like when, for instance, let's just do a quick what if. So what if we have an environment that certain devices, certain assets can't leave my space, and so we're tracking those either by Bluetooth or Wi-Fi or RFID tags, and we create geofences around our workspace. And so if a laptop per se leaves that space immediately, well, the sensors kick off. The map shows me where the last known location of that thing was, and then an alarm inside my asset management system says, "Hey, you need to go and address this issue immediately because someone just walked out of the space with a secure device." Right? That could be one aspect. It could be asset-based tracking. It could be network-based data moving in and out of networks, sensors. But just think about it. Routers and things like that could be sensors on a network that are tracking certain things that are happening within your space. Again, sensors just aren't what we're traditionally seeing on our phone sensors or stream gauge sensors or rainfall. I like the idea of you thinking outside the box and where else can this be? There's lots of opportunities like this. Good question.
And Steve, this is George. I would go ahead and add to that interruption of just our services, water quality disruptions, and just not getting water. So those are all security related matters as well.
And also too, we learned this the other day. George and I were together, kind of preparing for this, and from an EPA environmental standpoint, right, using citizens to help us, when they smell a gas leak or smell something that's not behaving, or environmental sensors out there that are tracking this information can also trigger these same kind of events.
Excellent.
Good discussion here. Yeah.
Yeah. All right, well, we'll go ahead and wrap up. Our next webinar will be Thursday, September 13th, 11 a.m. Central. It'll be titled GeoIoT Asset Tracking and Analytics. As a reminder, you must register for all of these webinars individually by going to the link. You can see it there at the bottom of the screen. Within the next week, you'll receive an email with the webinar recording and link. And just as a brief reminder, there'll be a short survey that will come up on the screen once I finish speaking. We greatly appreciate you taking the time to answer them. Thank you so much for joining us and have a great rest of your day.